Inequalities. So we're going to talk about inequalities and how we can graph them on a number line. And whenever we talk about inequalities, we talk about less than, greater than, less than or equal to, greater than or equal to. And there's some definitions that you can read up on. I just want to jump right into the actual math of it all, and let's just talk about it. So we have an interval notation, right? It is written as smaller number to larger number every time. So you'll notice this is interval notation. This is the most common notation that you are going to have to write and interpret. This column here is my set builder column. You will see it, but you're not asked that often to write it in that notation. I'm going to read it to you here in a minute. This column here tells us the type of interval it is, and I'll explain that to you as well. And we're going to graph. We're going to create our own number line right here for it. So let's read it. So let's start with what does open interval mean? It means that that point is not included in there. It's open, that is, continuous. It's getting as close to that point without actually hitting it. And how do I know that? Look at this. These inequality signs do not have an equal sign on it. So this is telling me that all the points around it are not equal. You know, the line's going to bump up as close as it can to it without actually including that point. So let's read this set builder. It says that we have this set right here. We have this set of x that builds on where x is greater than a. Again, we have a set of x that builds, that builds on where a is less than x, where x is less than b. Kind of get it? Have a set of x that builds on when x is less than b. So the interval notation says that we have a to positive infinity. How do I know this? Well, let's draw this out. Because usually the interval notation comes easier if you can put it on the number line. And my number lines are just a little wavy, but y'all kind of get the point. I'm going to put 0 in the middle. And we don't know what the value of a is, so I'm actually going to change the 0 and make it an a, just because I don't know what the value of a is. It could be a negative number, a positive number, or it could even be 0. Let's just call it a. And let's read this notation. It said that x is greater than a. Well, if that is true, then that means that the point on a is an open circle because it's an open interval. Okay, there's no equal to sign. And it said x is greater than a. So that means we're going to go off to the right. How do I know that? Because the values to the right are all positive infinities, right? They go off to that way. The values to the left goes off to negative infinity. Okay? So now I can write my interval notation. Since it's open on a, I know it's going to get a parenthesis. And infinity does not ever get a bracket. It always gets a parenthesis because you cannot close infinity. You can't stop infinity. So let's do the next one. It says that we have a is less than x and x is less than b. So let's draw that out right quick. We have a and b on here. So I'm going to put a probably about right here, and b about right here. And there is no equal to sign on a or b. So I'm going to put an open circle because it is an open interval. And it says that x falls between those 2 points. It falls between here. So that's where we get this interval notation of parenthesis a comma b parenthesis, where it's an open interval and the value that we're looking for falls between those 2 points. Now let's do the next one. The next one says that we have x is less than b. So let's put b on here. It has no equal to sign, so it gets an open circle. It's an open interval. And it said x is less than, right? It's less than b. So we're going to go off to the left because it goes off to the negative infinity. And that's where we get this interval notation. So let's talk about another notation. This can be this is actually half open. what does it mean? It means it's closed on one part of it but open on another part. So how do I know that? It's because of this equal to sign on my inequality. Right? And it wasn't on both of them. It was just on this one. This is telling me that some value over here is going to either get bigger or smaller than the point we're solving for, and we're going to include it. So let's do the first one. The first one said that x is greater than or equal to a. So since it's equal to, I'm going to put a closed circle. And it said x is greater than, so I know we're going to go off to the right. So this is where this notation comes from, because we're going to put a bracket on a, because we're closed. We actually included a, and we went off to infinity, so we put a parenthesis. So let's do the second one and move on just a little bit. So we have a, we have b, and when we read it, it says a is less than x, but it's not included, so it's an open circle. It said x is greater than or equal to b, so that's a closed circle. And it said x fell between those 2 points, right? It's opened at a and closed at b. Okay, so y'all kind of get the idea. These says that actually closed because it says that this point falls between A and B, and you are including A and B. So if I was to draw this out on the number line, and I was to shade in the points that we are including, and since it said it was equal to, I got a little sloppy right here. I didn't mean for it to go past this line right here. We're going to put a closed circle, and we're going to put brackets. So this is where this notation came from. Now, this next one says that we have a or, right? This is telling me that I have points. Let me draw it right quick. I have points on a number line, and we're not using all the points. So this says x is less than a. So if x is less than a, then I need to go off in this direction to the left. And then it said x is greater than b, so I need to go off to this direction on the right. So if you notice, the points between them are not included. So we're going to say that negative infinity to a, and since it's not equal to sign, we're going to have it a parenthesis here, right? And we're going to call it a union, right? We're going to say or the b to positive infinity. If you ever see the word and, if you ever see the word and here, then that changes up everything, and then it's going to be an intersection, or it's going to be, there's going to be other things. But as for right now, guys, what you need to know is that or means it sometimes not all the points are included. Like right here, we included those points, but here we did not, okay? And then it says x is equal to a real number. It just means any real number. So it would be the whole number line. So I would like to solve this one here. Let's solve for it. So what we need to do is subtract the 5 from both sides. So now I got negative 3x is greater than negative 7 minus 5, which is a negative 12. And we got to get a positive 1 coefficient on x, so we have to divide by the negative 3. Since we're going to push the negative sign across the equality, it actually flips it. Negative divided by negative is positive. 3 goes into 12 4 times. So when I go to graph this on the number line so I can write my answer in interval notation, it says x is less than positive 4, so we know it's all points on the left-hand side. So now I can write it out in interval notation. So it's going to be negative infinity, comma, positive 4, and bracket. Oh no, not a bracket, apologize, because there wasn't an equal sign. See how easy that is to do? So definitely double check your answer because there's no equal to sign on the inequality. So this is my answer in interval notation, and this is my answer in set. Okay? And let's do maybe, let me find one. Let's do this one here and then we'll be done. Alright, so we see that we have a lot more going on, right? We got some value in the middle going on. So we need the variable to be isolated by itself in the middle. So what I'm going to have to do is subtract this 5 from all points. So I got -2 minus 5 is a -7. It's less than 3x. Less than 20 minus 5, which is 15. So now I'm going to divide by 3, and since it's a +3, we're not flipping the inequality signs, okay? So don't forget that. If it is negative, you got to flip them. So now I got -7/3 x, less than x less than 3 goes into 15 5 times. And if I was to go put it on the number line, -7/3 and then 5, and since they're open intervals, we're going to have an open circle, and it said x fell between those 2 points. Whoops, right there. Let me erase this. There you go. And now I can write my interval notation. It's parenthesis -7/3, comma, 5, parenthesis. So I got my set, my interval notation, and my number line. Let me skim right through this one more, see if there's one more. Yeah. I think we're good. Thank you.